Welcome, everyone. The name of the project presented by our group today is Prompt-Based Text Matching Methods for Fake News Stance Detection. And the members of this group are Zeyong, Yuqing, and Feng. This presentation includes the following. The problem is to explore how AI could be leveraged to combat fake news. The inputs of this task consists of two parts, news headlines and news body text, which may come from the same news or different news. The outputs of this task is the relationship between the news headlines and news body text. We can see that four body texts are similar in vocabulary, but there are obvious differences in semantics. The algorithm related to text matching can be divided into three main phases. The first stage is based on traditional statistical methods. The second stage is an NLP approach based on deep neural networks. And the third stage is a pre-trained neural network-based approach. Now to introduce the data given by fake news challenge. In the training phase, the training data are headline, body text, and label. Then we will introduce the construction and the use of the first pre-training model.
Because the original news text is placed in body CSV file, and the news headline is placed in stand CSV file, the two texts need to be associated with each other by body's ID before training. In this step, we prepared a pre-training model for BERT, which relies on high-performance computing devices. So, our group rented Google Colab Pro Plus, which provides a cloud server with TPU. We then downloaded the BERT pre-training model from the Hugging Face open source transformer model. For first step, we need to convert the text into BERT encoding. Here, the role of the tokenizer is to convert the text into a series of token IDs, which correspond to the word is in the pre-trained model. Second step, all the encoding should be packed into a dataset, which is used by PyTorch to extract the batch and shuffle. Now we can start fine-tuning, either using the native PyTorch code for fine-tuning or using the Hugging Face wrapped higher-order functions for training. We only need to define training arguments and trainers to perform fine-tuning very efficiently. Here, we introduce the content of the evaluation. The fake news challenge computation also prepared FNC score as a special metric, which is defined as follows. And the process of evaluation is via this flowchart.
From the perspective of ROC curves and AUC values, the logistic regression model using TF-IDF coding has the best results, with its micro-average AUC and macro-average AUC exceeding 90%. We can see that the ROC curve of our BERT model is very close to the upper left coordinate points, and its macro-average AUC reaches 97%, and the micro-average AUC reaches 99%. The effect of the BERT model is much better than the four baseline models. Well, a comparison of the performance metrics between the BERT model and the four baseline models is shown here. The BERT model exceeds 90% in the fine matrix, and the BERT is the only model with a score of over 10,000. However, there are still some shortcomings in this project that needs some more research by our team in the future. The first limitation is that we did not incorporate the FNC score into the loss function of the BERT pre-trained model, and we do not understand the BERT model and the natural language processing paradigm of deep learning well enough, which is something we need to do further in our future research. Here are the reference pages. That's all. Thanks for your watching.